Therefore, ladies and gentlemen, if you see a linear equation, you know what we mean by that? First degree, just x's, y's, nothing squared or anything. Nothing fancy. If you see a linear equation with x's and y's, does that represent a function? So you got to actually move logically 2 steps. Let's see, linear equation with x's and y's, that means a slanted line. Does a slanted line constitute a function? Absolutely. Passes the vertical line. So that's your way of thinking. X's and y's in this linear equation, slanted line, passes the vertical line test, function. Hey, what's the slope of this guy right here?
0.
Very good. Horizontal line has a slope of 0. Does every horizontal line constitute a function?
Yes.
Yeah, because passes the vertical line test. How about the slope of this guy right here?
Undefined.
Slope is undefined. Does that pass the vertical line?
No.
Is there a vertical line that cuts that line in more places than one? Intersects it in more places than one?
Yes.
Which one? This vertical line, the line itself, intersects that line in an infinite number of places, right? So, not a function. This guy does not pass the vertical line. In fact, I hate to use this word in a math class, ladies and gentlemen, but this line fails the vertical line. Some people get cold sweats when I say that word in a math class. Fails the vertical line. So you got an observation here, ladies and gentlemen. If I said every single line represents a function, true or false, what would you say?
False.
False. If I said every single line except vertical lines represent a function, what would you say?
True.
True. So the only exception to being a function is vertical line. That's the only one that fails, again, my apologies, fails the vertical line test. All right? Tell me about this guy.
It's a circle.
It's a circle. Keep going.
It's not a function.
Hang on a second. Tell me about this circle. Center is 0, 0. Radius is 5. Y'all remember that? If it starts out x squared plus y squared, that means its center is right there on the origin, and its radius is 5. So it goes through these points, step it around. That is the technical name for that is a donut. That is not a circle. Hey,
It doesn't pass the calorie test.
represent a function? Why not? Fails the vertical line. Now let me just, before you make a real quick decision on this, what if I said I can show you an infinite number of vertical lines that do not cut this graph in more places than one? I will show you an infinite number of vertical lines that do not cut this graph in more places than one. Would you be convinced that I have a function there?
No.
Why not?
There's at least one does.
Because there's at least one. Well put. There's at least one line, and you have no problem finding it, right? There's at least one line that cuts this graph in 2 places. So it is not a function. Sorry. I was feeling a little down. Now I'm moving, all right? Juices are flowing. All right. Okay, ladies and gentlemen, will a circle ever be a function?
No.
Okay, even a real small circle? Even like way over there in the corner? So if you got the equation of a circle, you basically can conclude immediately, well, the thing is not a function because it fails the vertical line. All right. One thing we're going to use often is something called function notation. We already looked at it. There's your old parabola. There's your quadratic equation in x, right? Y in terms of x. Function notation represents exactly the same set of ordered pairs. It's just in a different phraseology. It looks like this. That's called function notation. Now notice what two things are interchangeable. Did you notice that? Y and f of x are interchangeable. They're synonymous. They're different ways of saying the same thing. Sometimes you're going to want an equation with a y in it. Well, use the top expression. Sometimes you're going to want an expression that is in function notation for the sake of what you're doing. Choose f of x. So the same thing results in the same set of ordered pairs, the same graph, different notations. All right, let me give you a little picture of a function that I think will be helpful. I like to think of a function as a computation machine. It's a mathematical machine. And functions have different names. Let's call this guy 3x plus 5. So if I was talking about this function, I'd say f of x equals 3x plus 5. There's an infinite number of functions. This is just one of them. And this function, by its very name, tells you what it does in this computation machine. I take a value, I pick any value I want, I pick a value and put it as input into this machine, and this machine does one thing. It multiplies it by 3 and adds 5. That's all it does. I mean, 24/7, 365 days a week, no coffee breaks, no days off, all right? No leave, doesn't matter. That's all it does. Very boring existence. That's all this function does. Multiplies by 3, adds 5. So if I have a mathematical input, this machine does its computations and spits out, in this case, what value? That's right. Here's what it says. It says, oh, you give me a value, you give me a 3, I got one thing to do, multiply by 3, add 5. That's all I do. I multiply whatever you give me by 3 and add 5. 3 times 3 is 9, plus 5 is, spits out 14. All right, it's a mathematical computation machine. That's all it does. So if I give it 10, what's it going to spit out? Yeah, it says, whatever you give me, we call them x's. I multiply by 3, that's 30. Add 5, that's 35. What if I try to throw it for a loop? I give it a negative number. It says, are you kidding me? I do this 365, 24/7. I can handle a negative number. Multiplies it by 3, negative 6. Add 5, negative 1, and spits it out. What if I gave it a general expression like A? What's it going to spit out?
3a plus 5.
Yeah. Still does the same thing. You give me an A, I multiply by 3, add 5. 3 times A, 3a, add 5, 3a plus 5. All right, everybody get this one. Don't say anything out loud. What if I gave it an A plus 2? Don't tell me your answer. Everybody work on it. I'm guessing you either got 3a plus 7 or you got 3a plus 11. Did everybody get either one of those? What do you have to remember after you do the input of a plus 2? Distributive. That's right. I have to apply the distributive property because this function says, hey, you give me something, I multiply by 3 before I add 5 to it. Right? That's 3a plus 6 plus 5. 3a plus 11 is right. Okay? So whatever you give it, even if it's a quantity in parentheses, it multiplies it by 3, adds 5. Hey, can you tell from what we have up here what the domain elements are that we have listed? Yeah, these guys right here. This is our domain. That's our range. Domain is what we input. The range is the set of outputs. I want you to notice something else. Every single time I do this, I create an ordered pair. Anybody see any ordered pairs up there? What do you see?
3, 14.
3, 14, absolutely. I could write it that way. What else?
10, 35.
And what you would discover if you graphed all of these points is that they make, anybody want to guess? Y equals 3x plus 5. What do you think it's going to be? It's got x's and y's. A slanted line. Yep, I got myself a slanted line. If I were to graph all these points, 3, 14, 10, 35, negative 2, negative 1, they'd be in a straight line. Remember, f of x equals 3x plus 5 is the same as y equals 3x plus 5, depending on how you want to look at it. That's how we looked at it last time we were together. Y equals mx plus b, right? That's a plain old line with a slope of 3 and y-intercept is positive 5. All right, here's one thing you're going to be asked to do. You're going to be given the expression of a function. You're going to be given the expression of a function, and you're going to be asked to evaluate that function when, in this case, x equals something. Okay? And the way you're going to be asked to do that is this. G of 5 equals. That's what they're going to tell you. You're going to say, what's G of 5? And what you're going to think is, well, what this means is, everywhere there's an x, I'm going to be putting a 5. So G of 5 means 2 times 5 minus 7. It simply means evaluate the function at 5. So everywhere there's an x, no way to put it, there's a 5. So G of 5 is 3. Hey, can you get an ordered pair out of this thing? This thing I just said? 5, 3. Input, output. I put a 5 into the mechanism. It spits out a 3. That's another representation of an ordered pair. How about G of negative 4?